The purpose of this panel session right here is to start talking about all of the positive non-military uses of this technology, specifically targeted to benefits in Florida. So it's not about regulations, it's not about policy. That was very well covered by Grant and his panelists. Many of them are staying through here and will be available for questions during the lunch period and the afternoon break, and also in the social networking period this afternoon that we hope you can all stay for. The purpose of this panel is to talk about what kind of uses, what kind of positive, beneficial uses will these aircraft have in the state of Florida. So we've assembled a panel of experts that are looking at what is the benefit, what kind of things can we sense, what kind of economic benefits can come to the people of Florida, and that is the purpose of our discussion here this morning. So first up, I'd like to introduce Dr. John Robbins. John is an assistant professor at Embry Riddle Aeronautical University in Daytona Beach. His research interests include engineering and safety issues currently affecting the aviation community, UAS applications, and extension outreach, curriculum development, and implementation. John has a Bachelor of Arts degree in geology from the University of Florida, a master's degree in aeronautical science and education management, dual specializations, and a PhD in agricultural and biological engineering from the University of Florida. He's also a commercially rated pilot, both fixed wing and rotary wing aircraft with a total flight time of 6,000 hours. Additionally, he teaches unmanned aircraft systems, flight techniques, analysis, and unmanned aircraft systems robotics at the undergraduate level and aviation aerospace psychology at the graduate level. John's going to talk to us about the agricultural applications for UAS. Please join me in welcoming John Robbins.
Good morning, everyone. I certainly appreciate your time. Talking about the agricultural industry and uses of UAS is really unbounded, and we'll see the potential growth over the time that they are implemented through the next 10 years. It's going to be really significant in the whole scheme of things. All right. So industry as a whole, we're looking at $84 billion in revenue over 10 years after implementation. That's huge. You know, some of the issues, I know that you've talked about regulation. I have one slide in there. We'll just kind of peruse it briefly. But wide-scale agricultural solutions, especially in the state of Florida, we look at citrus as one of the main crops, and we have some significant problems where UAV technologies can be of significant benefit. Enhanced imaging systems, you know, some of the systems are becoming miniaturized with better hyperspectral imagery, multispectral imagery, LiDAR. AUVSI had a really interesting LiDAR system out. So the stuff's being miniaturized and it's able to be supported by multiple platforms as the platforms become smaller. All right, software development, some of the software that's out there, like Mission Planner. I don't know if anybody's familiar with that, but it's open source software you can get, and we use it in class with the AR drone or the Flame Wheel 450, the DJI quadcopters, and it gives us telemetry data. It gives us a multitude of different things that's very easy to use. So that's a good thing. Pix4D, Agisoft, and some of the aggregate software that's out there when you actually purchase a system. So we'll take a look at that, and then I really want to discuss some of these issues that really pertain to Florida agriculture, like citrus greening. It's one of those things that has the potential to kill the industry, and or at least significantly, you know, break down the industry. So that's something that we need to control, and UAVs or UAS is a good way to do that. All right, regulation. I know that everybody's familiar with it. You've talked about it. COA, Standard Airworthiness Certificates, the 333 exemptions. 333 exemptions are finally coming out, and they're a good thing. They're promoting safety in the industry, right? And they're promoting synergy amongst industry, right, with the production of SMS and flight operations manual standardization, just like we have in the manned aircraft side. And the new notice for proposed rulemaking that came out. I know that you've talked about that as well. All right. So we look at these enhanced imaging systems and the uses as they pertain specifically to agriculture. You know, a lot of organizations are using the visible spectrum. They're using regular electro-optic cameras. One farmer came up to me and he said, I can fly over my field in 10 minutes with my Cub, and I can see exactly what's going on, right? And he said, there's no need for UAS technology. I said, okay, well, let's think about that critically. Can you really see what's going on? If you send somebody else over your field, are they going to be able to identify the same problems that you identified? So there's no, well, not necessarily validity, but there's a lack of reliability as you move forward. With the remote sensing systems, you get that reliable, valid data that can be supported and it can be used over and over again. So that's one of the areas that I talk about later, is that actual trend analysis. Right, because trend analysis is extremely important with agricultural operations. All right, thermal imagery, looking at canopy temperatures, things like that. We can tell a lot from a plant's canopy, right? If it's not transpirating, if it's not pushing water out, whatever, we know that there's some kind of systemic issue. We know that we need to go investigate that more, and that's an easy way to determine that there's some kind of issue. LiDAR is huge. You know, it can penetrate the canopy. We can get things like tree heights. We can get more specific variables. And then the multispectral imagery, of course, and then the hyperspectral, utilizing more bands. Okay. So some of the things that we see in Florida specifically with citrus greening. Citrus greening is a massive problem. It's produced by this little Asian citrusillid. They come over, they infect the plant, and it causes basically a systemic issue, and you have necrosis of the leaves. You can see there, this is from AUVSI, Institute of Food and Agricultural Science. They do a lot of research with this stuff. You can see that the leaves are actually exhibiting a lot of yellow, all right? It's pretty easy for a scout, for a farmer to go through and say, I have a citrus greening problem, but what other problems are associated with it? Citrus canker is a bacterium. What happens is you get this little sore or lesion that appears on the plant, and it'll try to defoliate. Citrus canker was a massive problem about 10 years ago. They used to go in, they actually used to physically burn the trees, okay? And that was a major problem for the farmers. Now it's looked at as something that's treatable, but it does provide an issue for the long-term yield of the plant. Some different organizations are using different methods to try to mitigate that the best they can. You got Phytophthora. Phytophthora is a root rot issue. It's due to AUVSI, which is basically a plant pathogen or soil pathogen. Too much water, too little water. We've got irrigation, chemigation. Right? Chemigation, we're actually implementing plant essential nutrients. We've got 17 of them. We're using nitrogen, we're using phosphorus. We're implementing that into chemical systems, and we're dispersing that over wide-scale use. And then we're looking at the trend and how that trend changes over time. All right, nutrient plans is one of the major areas where I think agriculture will significantly benefit from the use of UAS and the use of the remote sensing systems that we have. If you think about it, all these problems, they're treated a certain way. Different companies, different large companies may come out with a specific treatment plan, which may vary. All right, the farmer goes out, they talk to a crop advisor, the crop advisor sends them to the right person. They come in and they have a nutrient plan that's developed for their specific problem, their specific farm, their specific crop. Okay, over time, it's important to determine that trend analysis. So just like with the insurance companies that are out there doing change detection, it's really change detection at the agricultural level. So we're looking at how effective a nutrient plan is over a specified amount of time, whether that's quarterly or whether that's monthly, whether it's weekly, whatever. You can do that very effectively using UAS systems. But it's important to consider that UAS will really push forward the integrated pest management approach. Integrated pest management is one of these terms that's come out, and it really follows the environmental side. And what it encompasses is using cultural controls, mechanical controls like furrowing, tilling at the right time, biological controls, ladybugs, wasps, parasitic wasps, things like that. I was just on a farm recently, they released 50,000 parasitic wasps to kill the Asian citrus psyllid to reduce their greening issue. So that's another thing that can be viewed, through that change detection type analysis. Okay, and then of course you have pesticides. Well, we want to try to mitigate or minimize our use of pesticides. We want to use more of the other practices to enhance agriculture, because insect populations become more and more resistant. And most farm communities do use pesticides in a manner in which the label says. If you use it outside of the label restriction, then that's where you run into problems. We have serious issues with pest resistance. Okay. Some of the aircraft that are out there, like the Air Tractor 602, it weighs 16,500 pounds and has an 850-gallon hopper. It's hard to compete with that on the UAS side. But I think for UAS in specific, where it starts with aerial application is spot application, right? Very controlled and effective spot application of pesticides, fungicides, caricides, whatever, to support whatever the issue is. The other side of the aerial application arena is regulation. It's very, very tough, especially in Florida. We have a lot of aquatic environments. The pesticides that we spray can significantly affect invertebrates like gastropods, mollusks, and fish populations, things like that. So it can cause some ecosystem type issues. So we're trying to see where aerial application needs to go and what the best way to get there is, what the best platform use is. All right. Software-wise, we have a number of different things. Like I talked about Mission Planner. It's an open software, Pix4D. Pix4D is extremely popular right now. You can get all kinds of imagery from it. You can get orthographic, NDVI, SDVI, all kinds of different things, and the interface is very usable. Same thing with Agisoft. Both of these, I don't know if Agisoft does, but Pix4D will provide you with a monthly subscription to the actual product, so you don't have to go out and buy it all at once. You can try their versions. They're very good. I went to a seminar on that recently with TetraCam. TetraCam is a camera that's really used for NDVI type imagery, normalized different vegetation indices. So that's one of the areas we were using it. And then system integrated software. I don't know if anybody has an EB, but the EB comes with software that integrates Pix4D into it. So it's basically a full package where you can get a lot of support for your particular system. Other than us for support, I definitely want to say that the University of Florida provides a high level of support. Really, any state institution, land-grant university should have a cooperative or an extension program that will support agriculture in specific. The University of Florida, that link up there, which I'm sure you'll all get a copy, provides all the contact information for each particular county in the state of Florida. And the extension cooperatives, that's what they do. They go out and they study these problems and they look at the best ways to solve the problems. They're getting very heavy in the use of unmanned aircraft systems. We have a high school program that's actually pushing agriculture in the high schools through some of our coursework to implement this technology, because we know it's going to be such a major benefit to industry. Okay, so with that said, I will sit back down, let the next person go, and feel free to ask me questions.